Today, we're going to talk about a discovery that is, frankly, revolutionary. And it's hidden inside something most of us think of as a symbol of perfection, a diamond. But it turns out the real power might just be in its flaws.
You know, we're always told that the best diamonds, the most valuable ones, are completely flawless. But what if that's not the whole story? From a scientific view, the really fascinating diamonds, the ones that could literally reshape our technology, are the ones with tiny, tiny imperfections.
And that really brings us to the big question for today. What if a single atomic-sized flaw is the very thing that makes a diamond not just valuable, but scientifically, well, priceless?
To get our heads around that, we need to zoom in on one very specific, very special kind of flaw. It's called a nitrogen-vacancy center, or just NV center for short.
So what is an NV center? Okay, think of it like this. It's a tiny defect, a mistake at the atomic level, right inside the diamond's perfectly ordered crystal grid. It's almost like a deliberate glitch in the system's code.
And here's how you make one. It's actually pretty simple. You start with the perfect carbon lattice of a diamond. Then, a single nitrogen atom muscles in and takes the place of a carbon atom. And right next to it, a spot is left totally empty. That's the vacancy. That's it. That combination, a nitrogen atom next to a hole, creates this incredibly powerful quantum device.
So what makes this little flaw so special? Well, it all boils down to a weird quantum property called spin, and the fact that the diamond's super rigid structure keeps it incredibly stable. So this defect leaves behind an electron all on its own, and that unpaired electron has a property called spin. The best way to picture it is as a tiny microscopic arrow, or maybe a magnet. It can point up or it can point down, and the direction it's pointing is extremely sensitive to everything around it. And listen, this right here is the absolute game changer. Most quantum systems are ridiculously fragile. I mean, they have to be cooled down to near absolute zero to even work. They're thrown off by the tiniest vibration or change in temperature. But the NV center, the diamond itself acts like the perfect little protective shell. This makes it stable and functional right at room temperature. That is a huge deal if you ever want to build real-world tech with this stuff.
So you've got this stable little quantum arrow. What can you do with it? Well, its first superpower is the ability to sense the world on a scale we could barely imagine before.
So how does it actually work as a sensor? Well, remember that tiny arrow? It acts just like a compass needle. If there's a magnetic field nearby, it makes the arrow wobble. Now here's the cool part. Scientists can measure that wobble with insane precision. They just shine a green laser on it, and the NV center glows red in response. The brightness of that red light tells them exactly what the magnetic field is up to. It is an unbelievably sensitive measurement.
And the potential applications for this are just wow. We're talking about things like detecting the super faint magnetic signals from neurons firing in your brain, or spotting microscopic metal impurities in new materials, or even finding tiny invisible cracks in a bridge before they become a big problem. All of this from one little flaw in a diamond.
Okay, so sensing with one atom is amazing. But what if you could get trillions of them to all work together in perfect sync? Well, that brings us to the main event here, the quantum bucket brigade.
First, just a quick definition so we're all on the same page. Everyone knows what a laser is, right? It amplifies light. Well, a maser does the exact same thing, but for microwaves. It creates a really powerful, focused beam of microwave energy. And this is exactly what scientists managed to do. They built a maser using a diamond that was just jam-packed with trillions of these NV centers. And the keywords here are room temperature and superradiant. Superradiant means all those NV centers act as one, totally in sync, to create this incredibly powerful, super-fast pulse of microwaves. And they did it without any of that crazy cooling equipment. So how on earth did they get trillions of atoms to cooperate? They used this incredible process called the quantum bucket brigade. It works like this. First, a green laser zaps all the NV centers, basically loading them up with energy. Then, just one of them spontaneously releases its energy. Now, here's the magic. That now tired NV center immediately steals energy from its excited neighbor. This sets off a chain reaction, a wave of energy transfer that sweeps through the crystal and forces all the NV centers to dump their energy in one massive synchronized blast.
You know, here's a great way to think about it. Imagine you're at a concert and one person cheers. That's fine. But now imagine the entire stadium cheers at the exact same moment. It's not just louder, it's a massive physical roar. That's the difference. That's synchronized power. That's superradiance.
Okay, so building a diamond maser is an incredible achievement, but let's get down to it. What does this actually mean for us, for the future?
This is where it gets really exciting.
The possibilities here are just astounding. This tech could lead to things like ultra-sensitive medical scanners that can image the brain in incredible detail, without the giant, noisy machines we have now. It could be the foundation for brand new parts in quantum computers or unhackable communication networks. It could even give us stronger, way more precise signals for things we use every single day, like GPS. We're really talking about a fundamental new tool for science.
So you see, it all comes back to this one idea. For centuries, we have been obsessed with perfection. But this whole breakthrough forces us to ask a really profound question. Could the next great leap for technology, the key to unlocking the whole quantum world, be hiding not in perfection, but inside a simple imperfection?